Alrighty, howdy there, this is Mr. Steele, and I'm here to start going through some of the pre-calculus standards for Term 3. So what I'm going to do is, like for example, I'm going to start and do Standard 14 right now. So what I'm going to do is I'm going to go through kind of some general strategies here using some of my stuff from the PowerPoint. Then I'll kind of show you a couple examples, one or two probably, and then call it a day, and hopefully this will be helpful. So to start off, I'm looking at Standard Quiz question number 14, which is on the back side. So it's probably one you get to as you're kind of getting tired at the end of the quiz, but at the same time this is one that there's really not a whole lot of writing work that you need to do. It's not something that you have to do by hand. It's really something that we've designed for you to use the graphing calculator on. So that's what I'm going to actually do, is I'm going to do this problem right here and show you how to use it on the graphing calculator. So what we want to do is we first of all need a graphing calculator. So I don't know how I'm going to do, oh look at that, there's a graphing calculator. So I will have that taken care of. But first, just kind of looking at the strategies, what we're going to do is we're going to use our graphing calculator to graph these two functions, then find where they intersect, because a point of intersection is a solution. We'll make one side of the equation y1, one side y2. I'll show you that in just a second. And then we'll find the intersection point on the calculator and write down just the x value, because we're just trying to solve for x. So here we go. Let's actually do this. So there's my calculator. Turn it on. Hopefully it works. Yep, it works. Good deal. So we're going to go up to y equals, and we're going to graph this thing. So what we want to do is we want to do one side as y1, one side as y2. So I'm going to make this side y1, so the first equation, and then I'll make this side y2. Okay, so let's do this. So I'm going to bring my mouse down here because this gets kind of annoying after a while. So let's see. Okay, so we need to plug these in. So first off, log. So log of 2x plus 1 is going to be my first equation. So there it is. Those parentheses look kind of funny on there. Make this a little bigger. There we go. Maybe that'll help. And then the second one is the square root of 5 minus x. So square root. The 83 gives you the parentheses for you. Minus x. And there we go. There are our two equations put in for y1 and y2. Okay, so now what we want to do is we want to make sure our window is big enough so we can see where the point of intersections would be. And so for these I usually go negative 10, 10, negative 10, 10. So I just kind of give it a general straight. And now what I'm going to do is I'm going to graph it. So here we go. Pressing graph. There's my first one. There's log of 2x plus 1. And there is radical 5 minus x. So as you can kind of see, it looks like my point of intersection is right there. But even so, I'm not going to trace define. I'm going to tell the calculator to actually calculate that point for me. So second calc, and we go up here and we get a list of options. So of course we want to find where they cross, so we're going to use option 5 to intersect. So let's see where they intersect. It asks me first for the first curve. So first curve, I'm going to say, okay, what the heck, I'll scoot over so I can clearly see it. Okay, so I'm going to use that one as my first curve. It asks me for the second curve, so it's trying to see which two graphs we want to find the intersection point for. So there it is. And then guess. So when they ask me to guess, they just want me to kind of go about where I think the point's going to be. And since we said that point's probably right around there, let's go right like that, and then press enter, and it will do the calculating for me. So there we go. It says here that the intersection point is 4.0755661 and y at 0.96147,483. Now again, we're just trying to solve for x, so my only value that I need is right there. So when I go to write my actual answer on this question, I'll do it right here on this piece of paper. All I've got to do is write down the x-coordinate. So in this case, my answer would be x equals 4.07. It says to 3 decimal places, I think, on the front of Standard Quiz. So there we go. So there is my answer, 4.076. And now again, we might have to check for a second solution if there was another point, but as you can kind of see, we've got the shape here completely. Like we've got the log right there. It's just going to keep them bigger that way. The radical's done right there. So in fact, looks like we found our answer. X equals 4.076. So again, all we did was we made the calculator do the work for us. Okay, so let's do another example. For this second example, I'm not going to do as much of the actual explaining. I'm going to go a little quicker since I think this is possible. But again, this would be an ideal time on the video if you're trying to practice for the standard quiz, that you'd kind of pause it yourself and then go try this on your calculator, see what you get, and then compare it with what I get. So here we go. So I want to solve this equation for x. So same kind of problem. Again, this one looks like it's probably something you could solve. I mean, x cubed minus 3 equals 1/2 x plus 2. I mean, that seems reasonable. You might be able to solve it. Maybe it factors or something, or, you know, there might be a strategy. But again, why risk going through that and not getting anywhere? So I'm going to use the graphing calculator. So there it is. Let's pull it up here. I'm going to pull my mouse in here because this gets really annoying. So let's go up to y. So there's my equations from before. So let me clear both of them. Okay, and we're going to type in this equation. So the first half, x cubed minus 3. So x to the third power minus 3. And then the second half, we'll make that y2. That'll be 1/2 x. And again, I'm going to be real careful with parentheses. Obviously, you don't actually need them in this case, but I'm trying to always be safe. So we have 1/2 times x plus 2. So there are my two equations. My window, negative 10 to 10, negative 10 to 10. It's pretty standard. Again, this should get us the graph because you can kind of imagine what we'll see. We'll probably see a picture where we've got a cubic and then kind of a line somewhere, so it'll just be one point of intersection. And so we're ready to go. So let's graph it. Now you wait anxiously. There's the cubic. There's my line. And I can see my solution. It's right there. It's staring at me. So I just need to write it down and get it correct. So let's do that. Again, we're going to second calc, or it's on the trace button, second trace. And then we want to actually find the intersection point. So there it is. We'll select enter. And now it's going to ask me to find, determine which two curves I'm looking at. So again, I'm clearly on the cubic right here, so first curve. There I'm on the line, so second curve. And now press enter right where I'd guess the answer is, so I think it's right there. And so as I do that, keep doing that. Okay, so as I do that, it says my intersection point is going to be x equals 1.807, and that's 1, 2, 3 decimal places rounded correctly. And so there is my final answer. X equals 1.807. And again, on our calculator, we get the x and the y, but we only need the x. Our final answer is just the x value because we're told to solve for x. Okay, so that'll do it for standard 14. Hopefully this one's a quick one. I mean, this would be one that if you're really trying to get a couple correct or you haven't passed this one yet, you know, do it early in the standard quiz. Punch in your calculator, since you're probably all using one, borrowing it from me or whatever. So go for it. Thanks. Hope that was good.